In the previous video we saw how to integrate sine of x and cosine of x, but it is more complicated to integrate sine of x squared, cosine of x squared and other powers of sine and cosine. So I will discuss some examples of how to do that. And the main feature in integrating powers of sine of x and cosine is to use the following relations that we already discussed before. Remind that sine of 2x is equal to 2 sine of x multiplied by cosine of x. And what is more important is that cosine of 2x is the difference of the squared of cosine and sine, and that 1 is equal to the sum of the squares of cosine and sine. Now this gave us a nice expression of the squared of cosine and sine in terms of the cosine of 2 times x. Let me recall, cosine of x squared is equal to 1/2 plus 1/2 times the cosine of 2 times x, and sine of x squared is 1/2 minus the same half times cosine of 2x. Now what you could do now is, if you want to integrate cosine squared of x plus sine of x squared, then you shouldn't make too much of an effort. You should realize that you do nothing but integrating the function 1, and the primitive of the function 1 is equal to x plus an arbitrary constant c. Now what is more interesting is, of course, the primitive of sine of x squared. In principle, you would be tempted to think that that is equal to something which has to do with 1/3 times sine of x to the power 3. But of course, if you apply the chain rule, if you differentiate and apply the chain rule, then what you get is, well, we have the term sine of x squared because we get the power is 3 times sine of x to the power 2. The power goes down by 1, multiplied by 1/3 is of course 1 times sine of x squared, but we have to multiply as well by the derivative of sine of x, which is equal to cosine of x. So the derivative of this function then becomes sine of x squared multiplied by cosine of x squared. So what we did is in fact calculating the primitive or a primitive of sine of x squared multiplied by cosine of x. But we didn't manage to calculate the primitive of sine of x squared. Now the way to do this is to look at this formula over here, because we know how to compute the primitive of cosine of 2x. So if we use the second relation, then it becomes quite easy to calculate the primitive of sine of x squared. And we do it in this way, by substituting sine of x squared by 1/2 minus 1/2 times cosine of 2x. And of course we can differentiate, we can integrate term by term. So integrating 1/2 is 1/2 times x. Integrating cosine of 2x, we saw it on in the previous video, is 1/2 times sine of 2x, so we get an extra factor 1/2 here, plus an arbitrary constant. And summarizing, this yields 1/2 x minus 1/4 times sine of 2x plus an arbitrary constant. Okay, of course the primitive of cosine of x squared can be calculated in a similar manner. We have to replace minus signs here by plus signs. Now suppose that we want to calculate the primitive of sine x to the power 3. Then again, a trick is to replace sine of x to the power 3 by to write sine of x to the power 3 as a product of sine of x squared multiplied by sine of x. Well, we don't do anything here, but we can replace sine of x squared by 1 minus cosine of x squared. So what we get is, if we delete the brackets, we have to calculate the primitive of sine of x minus cosine squared of x multiplied by sine x. Now we can calculate the primitives of both terms separately. The primitive of sine of x is equal to minus cosine of x. We are left with computing the primitive of cosine of x squared multiplied by sine of x squared, but as you saw before here, we did already compute the primitive of sine of x squared multiplied by cosine of x squared, and of course you won't be surprised that this thing is in fact nothing but 1 over 3 multiplied by cosine of x to the power 3 with an additional factor minus. So we get minus 1 over 3 cosine to the power 3 plus an arbitrary constant. Okay, of course it's always good to check that we did the plus and minus signs correctly by differentiating back. And then we see that the constant term disappears. Here we have plus sine of x. Here we get that the power goes down, so we get 3 times 1/3 multiplied by cosine of x squared multiplied by the derivative of cosine of x, which is minus sine of x, and indeed we get exactly what we started with. Now, note that what we did in here was again applying a sort of anti-chain rule in calculating the primitive of cosine of x squared times sine of x squared. So as a final example, I want to say something about computing the 4th power of sine of x. And what you do is, again, using this nice alternative expression for sine of x squared, and substituting this, so we get 1/2 minus cosine of 2x divided by 2 squared. And if you delete the brackets, you get the first term squared is 1/4 minus 2 times the product of the two terms, which gives us 1/2 times cosine of 2x plus the second term squared. Now you can see that you can that you get the primitive by calculating the primitives of the separate terms. So we get the primitive of 1/4 is 1/4 times x. The primitive of this one, well, we have seen this in the previous video, and the primitive of cosine of 2x squared can be calculated in the same manner as the primitive of sine of x squared. You can do this as a nice exercise yourself.